Hello all, welcome to my channel. In one of my earlier videos, I had discussed about how Spark internally treats null. That means how it treats when it's being compared, uh, when it is being used in function, and how internally in the Spark code base it is handled. In this blog, we will be going through how we handle explicitly nulls when we are doing uh, data pipelining or doing transformation on the data that does contain null. So let's get started. So null is it's something which is unknown, and we don't want to live with something which is unknown. We want to handle that nulls in our pipelines. If we don't handle nulls correctly, it can lead to arithmetic operations deviation from the expected results. For example, if we are trying to count something and null gets included in that, we might not want that, or it's maybe other way around. Let's say we are doing a group by operation, assuming that we have 1,000 rows, and because of nulls present in the column on which the aggregation is running, and because Spark skips null values when it is trying to do an aggregation, at that time we might not see the right result that we were expecting. Same if we have join and we have null on the join key, there also we will be missing some records causing data loss. Nulls, as we have discussed in the last video as well, if we do a group by on grouping key is a column which has null, so there will be one entry in the list of aggregated rows for nulls, and that will have separate value. Also, null might represent something which is not correct, not valid, or the information is not being captured correctly. So if we are able to identify nulls, we will be able to tell the upstream system that, okay, boss, whatever data that is being shared to this pipeline doesn't have the full information, or some information is missing. How do we handle those cases? And if, let's say, our pipeline itself produces nulls and the downstream consumers are not expecting that, then again it will be a challenge. So because the data pipeline that PySpark or Spark is talking to upstream and downstream, it is our responsibility as a pipeline developer to handle nulls. When I say handle nulls, it doesn't mean that we have to drop the rows or we have to fill. We can take many approaches, like we can just notify. So for notification also we need detection of the nulls, so we can detect nulls and then notify to the upstream system. And if we are producing nulls, or let's say for some reason our code base produces null, that needs to be handled and that needs to be notified to the downstream consumers as well, that okay, this case you will see null. So detection of null and, let's say, imputation or replacing null values is something that we should be we should be knowing, and that's the theme of this video, that how we handle nulls. So in Spark data frame has a method filter which we can use on a column to see whether that column contains a null or not. So this is detection of the null values. So is null is a function applied on a column. And if we run this, all the rows where this age column is null will be listed. So we can filter it out. So we can, after we have filtered this out, we can run analysis on that. Okay, how many nulls are there? Is there any pattern why certain age values are null? For example, let's say we have on the rows we have information about particular region, particular gender, and then we have age column as well. So is those null coming only from a particular region? Region in a sense, let's say, is it coming null because the data entry operator from where this data was getting collected didn't fill it properly? Is it localized to a system? So that is one way to look at it. Other can be that let's see what is the distribution of these null values between the different genders. Is it that the gender, let's say if it is male, female, or any other third gender, or we have other genders, is it the age is not coming particularly with male, particularly with female, or let's say other gender. So that kind of analysis we can do once we have detected this null value. This is very important because once we have identified that pattern, we can handle it, right? It's a same way we can do a reverse. Let's say we find out the total data set has, let's say, 1 million rows, and then we find how many of those doesn't have any null value in the age column. So in that way, we can calculate the percentage. So it is kind of doing the same thing in a reverse fashion. And also one uh, is null is a metadata operation. So it is very fast. Same way, we will talk about na.fill and na as well. But as it is good to know beforehand itself that is null when we check, is it this is something which is a metadata operation and it runs very fast. On the other hand, na.drop is something which scans the data row by row, and then also it looks at columns, multiple columns to see. So that is slightly slow. So we should be doing an exclusion in while we doing an na.drop. So this is we will come to na.drop as well, but let's go ahead with other things. For example, if you want to count how many nulls are there, so based on this when otherwise thing, we can check whether the column is null, and then we can assign a value of 1, and otherwise we can assign a value of 0, and in one go we can find how many nulls are present in this particular column. Then let's say we have identified the columns. So what one approach is that we remove the row which is having null because we don't know how to process the data. So we say filtered, and filtered record is there that whatever records is coming now will not have will only have null. Uh, it should be it is not null. So if I say is not null in here, it will only filter records which doesn't have null. Or if we say is null, then it will only filter the rows which have null. So based on that, if we filter on is not null, then we are dropping everything which was having a null. Now, let's say we want to drop based on certain columns. Let's say if we have a case where we want to uh, drop the rows which have, let's say, based on two columns we wanted to drop. So we have a drop, and it takes an argument of subset which says these are the columns on which I will check whether null is there or not. So let's say if you want to see whether age as well as salary both are null, or one of them are null, or uh, or none of them are null. So based on that, we will be dropping. And that's where there is a different method as well, df.na.drop. Here we get an option of specifying how in a sense now we will have both. If we say any, that means we will check in any of these columns. If we have null, the row will be dropped. But if we say all, it will check all the columns. If let's say age is also null and salary is also null, then only it will be dropped. There is another thing we can say. Let's say we have n number of columns. Like let's say we have feature that we are calculating of something in features ML sense feature, and then we see that we have 10 features defined. That we are expecting that whenever we do run this pipeline, we should see a 10 column feature, and let's say out of those 10 columns, we are getting 2 columns as null. So in that sense, we can define a threshold saying that, okay, we only want to drop rows which have at least n, or let's say 2 columns which have null. So at least null means if there is only 1 column which has null, we can say, okay, out of 10 features, only 9 features are there. We can still make an inference. But let's say out of 10 features, only 2 are missing. So in that case, we can say, okay, 2 is not good enough. Let's say that can be one way to look at it. Or let's say if we have, we can give a higher number as well, saying that, okay, let's say threshold is 5. So if of those all those features, if let's say 5 columns are there, which doesn't have of value, then we will drop. So this was one approach that we can simply discard the rows, drop the rows rather than doing uh, a filtering or processing the data. The other approach is to fill this data with something that is something that is more default kind of scenario. For example, let's say if we get age and we don't know that there is a null value in that. So one thing could be that we can give something like, let's say, 18 as age, which is something that we can assume that, let's say, we are talking about a voter list which is being processed. So people who are only above 18 will be part of the voter list, right? So it makes sense for us to use default as an 18 of that particular column. So based on this, we can define certain values, like we can define age can default value and fill wherever we are saying NA or null, we can fill that with that. Or let's say name is null, so we can provide an unknown category and saying that, okay, name will be unknown. So that is one approach. The other approach is to fill with for only population column. Let's say subset we have population column we want to fill with default value. Let's say population is not known, so we set it to 0. It can be 0, whatever number we want. So it is specific to one particular column. Here we are saying that in age, if there is a null, we want 18. If name is null, we want unknown to be there. So that's uh, one way of putting a specific value when we see a null. Also, one thing to note is Spark expects the type should be matching. For example, if the column, data frames column age type is, let's say, integer, then it's we whatever value default value we are providing should be an integer type. And if the name column is string, then whatever value we are providing should be in string type. We can't give, let's say, an integer in here and string in there, because Spark expects it to be a matching type. So that is one thing to know. We can also provide null with certain calculations. This is again this whole feature, what you call null handling comes in majorly in ML workloads where we do a lot of feature engineering. So in that case, what will happen is we don't generally provide a static value. We provide values which are dynamic in nature based on the data set's pattern. For example, uh, uh, the same previous example where we gave age as 18 in here. Rather than doing that, we can add a value. We can provide a value to all the columns which have null as an age with the average age of the data set. So what we are doing first, we are calculating the average, and then we are putting that average number as the default value. Again, this is something which is very much interesting thing to do. Let's say now, because if you see, if we have a lot of nulls, and let's say we have earlier average value was coming at, let's say, x, and then we added uh, uh, this x amount to, let's say, 100 records, then again if we calculate, the average changes. So there are other ways as well. For example, instead of simply doing an average, we do a sampled average and then provide that value so that the actual average which was there should be maintained. Or let's say we add a standard deviation in case. So those strategies are there to fill within a specific number. So first thing is our whatever function that we want or whatever algorithm we want to use to get to the value that we want to, we can get that, and then we fill with that value. There is another approach that we can say, let's say we have a record and we have, let's say, events coming for a particular person with an ID, and then we have age as an event. For example, let's say it is a YouTube click or YouTube like, and we are trying to find out what is the age bracket in which people are liking certain video and not liking certain video. But let's say for a particular user we have list of click events, and in one of the scenarios we didn't have the age. So it does make sense for us to see for that particular user if we order by based on their ID, and then we find out, okay, what was the next, or like we can do a partition by as well. So here we say window, then partition by the let's say the user's ID, and then order by timestamp, and then find out what was the previous or next. Like we can do lead or a lag based on wherever it is not a null, not null value, and then we get the age of that particular user. So this is called a sequential analysis. So we first find the a group of rows which are linked, and in that link we find the next or the previous, or in that window we can say whatever was the median first row or the last row. So that approach we can take to find out or to fill that value, that okay, what should be the value for this. As there is another, for example, coalesce is one example as well, where we can see if this column simply does it, this function simply what it does it, it will add a new column called age, or if it is already there, it will replace that with, it will check if the null column, the row, particular for a particular row, if the age column is null, it will put a literal value for that. So this is coalesce is a function which simply says text string of, or a list of values, and then it will return first not null value if it is present. Then conditional null replacement is something we can do based on certain conditions. Let's say this is with a is null, we are checking whether if it is null, then we are giving 0. Otherwise, we are taking the older value, whatever was there. This can be extended to other things as well. For example, we can check if this column is null, and we can add one more condition that okay, something else should be there. Like let's say some other row has certain value. Then we say that okay, we will put a value of, let's say, default 0 or 18. Let's say in this case what happens is uh, we are saying that the column, a certain other column, let's say date of birth is present, then we say we can derive the age from that. So we check if age is null and date of birth is present, then we do certain subsection and then provide that as the value. So this is a conditional null replacement that we do. This is something same like string, for example, we can simply say string to string mapping, age to integer mapping. This is just an example of matching types that we should be doing. Now, as we said, that for integer the default value is 0. If we want some specific number, we can provide that number as well. In this case, it is 18. So there are multiple functions like coalesce, null if null. So there are slight differences between them. So coalesce selects the first none value, but while null if checks the two expressions that are present. So it will check if the first expression, if the two expression that we have said is equal, then it will return null. Otherwise, it will return the first expression. So whatever is there. And in if null, what it does it is other way around. It will check if the first argument is null, then it will return the second argument. So if null only takes two values, while coalesce can take a sequence. So in sequence, we can keep on checking and find the first non-null and then return. While in if null, we are only giving two arguments. So this is an example where we are using null if. So if the column status is null, then we are saying that okay, take that this value called invalid. This can be same as we can do this as well, that uh, f dot when, then column check if it is null. Same statement can be repurposed as well. So this is another approach of another way of writing, and this is for the if null part. So if this is there and this is there, then it will say if and we have given just one column name. So if null is also something that we can use to replace nulls. Another important thing is to handle null in the schema. This is very important. Uh, so this is while defining the schema of that particular data frame that we are interested in. While we define the schema using the struct field, we have an option of giving a third argument is nothing but whether that field is nullable or not. So if we make this case and someone tries to insert or provides add a row to that particular data frame which is having null, it will throw an error at that time. So this is another approach. This will throw an error and job will stop. So we are preventing downstream applications from having a null value. Other thing is that all spark functions return null when the input is null, and all our Spark functions should return null when the input is null too. So what this means, what this line is, that inbuilt Spark functions return null when the input is null. So to be consistent, our function, let's say if we write some function and if we see any value null, we should also report it as a null. The other thing is how we handle in nulls in UDF. So we have to explicitly check and handle the null, how we should be returning. So what we are doing is, if it is s this is equal to null, we can simply say if s is none, if s is present or not, and then we say okay, something is there, and then we return. So this is another way of handling ourselves, that okay, whatever function we are writing should handle nulls explicitly. So if we do those things, handle null properly, we will have a data quality which is better. It will improve the data quality. It will prevent errors from happening. It will provide a accurate analysis, and also certain things which can improve is, for example, if we handle null properly, it might not create a skew value. Let's say if we have uh, category, let's say column is coming as null, and then we do conditional checks and then populate those based on other attributes of the data frame, then the chances of a skew happening in the data frame will be less. So it will enhance the performance of the job as well. So this video, when combined with this particular other video that we have for Spark and null, so how internally Spark handles null, if we have those two things combined, it will be it gives us a full-fledged end-to-end understanding of how internally Spark handles null and how we can handle nulls when we encounter them in our pipelines. Uh, One example, see, in how Spark handles null is, that's in the order by clause, they put the nulls first or last. So we can decide on that, and we can set which one to use. So for example, this is a function which takes decides whether the null should be first or last. So yeah, this is it for this video. If you like it, do share. We'll see you in another video. Thank you.